What makes Helmholtz free energy a state function? Imagine trying to figure out how much useful work a system can do without knowing the path it took to get there. That's where Helmholtz free energy comes into play. It's a key idea in thermodynamics that helps us understand energy and disorder in a simple way. But what makes it special is that it depends only on the current state of the system, not on how it got there. That's what makes it a state function. Let's break it down. The Helmholtz free energy is calculated by taking the system's internal energy, which is the total energy stored inside, and subtracting the product of temperature and entropy. Internal energy is a state function because it depends only on the current conditions like temperature, pressure, and volume. Entropy, which measures how disordered or spread out the energy is also a state function. Temperature, which tells us how hot or cold the system is another state variable. When you combine these, the Helmholtz free energy becomes a value that is fixed once you know the system's current properties. Now, why does this matter? Because in thermodynamics, knowing that a quantity is a state function means it's independent of the process. Whether you change the system quickly or slowly, the Helmholtz free energy at a specific state stays the same. This makes it very useful for predicting what will happen next. When the Helmholtz free energy decreases, the process can happen spontaneously, meaning it will happen on its own without extra energy input. When it stops changing, the system is at equilibrium, balanced and stable. This idea connects directly to entropy and spontaneity. If a process results in a decrease in Helmholtz free energy, it indicates that the system is moving toward a more stable, more disordered state. That's why it's so helpful in understanding when and how systems change naturally. It also relates to irreversibility and equilibrium, because systems tend to move toward states where the Helmholtz free energy is at its lowest possible value under constant temperature and volume conditions. In practical terms, scientists and engineers use Helmholtz free energy to design processes and materials. It helps them figure out how much work can be extracted from a system and when the system will settle into a stable state. Because it depends only on the current state, it simplifies calculations and predictions. So, in short, Helmholtz free energy is a state function because it's built from other properties that depend only on the current state of the system. Its value is fixed once the system's temperature, energy, and entropy are known. This makes it a powerful tool for understanding how systems evolve, when they change spontaneously, and how they reach equilibrium. It's a straightforward way to connect energy, disorder, and stability in the world of thermodynamics.